All right, so in these problems, it's kind of a foundational step to what elimination would look like, but the question is written so that we're looking for equivalent systems. And so with the idea that elimination is where we're going, elimination desires that we get a variable to cancel in a system set up like this, where we have two linear functions, ideally in standard form, and we want one of the variables to cancel if I could just vertically add like this. Well, if I added right now, this would be 4x's and then 8y's. Neither one of them canceled, so that's not ideal. So the job with elimination would be to figure out what's the easiest variable to get to cancel. And what's happening on here, it might not have chosen the easiest one in my multiple choice operation here, but I want to pay attention to where do I see some changes. Well, I see the y here change and the x here change to a -3. So what's happening is we're trying to distribute a -3 on this bottom expression so that way the x's can cancel or the y's will cancel. Something will happen. Now, we're not actually going through and carrying out elimination. We're just trying to see which one of these was done correctly. So we're kind of having to look down below to make observations of what might have been multiplied across the bottom expression. So then I'm going to go ahead and distribute this -3 to all three terms, so that I could see that the equivalent expression would have been -3x, and then -3 times 2 would be -6y, and then -3 times -19 should have been +57. And so the top expression, none of them changed, and so we don't have to worry about that part, but I'm going to leave it here. Plus 6y equals -57. Now, our job in the context of this problem is just to identify which of these below was correctly written. And that would be this particular answer choice, where this first one, the x didn't get distributed, the -3. On the second one, the 19 didn't get distributed. And on the third one, the y. Each one they chose one not to distribute, and this one was done correctly. So that's the right answer. But elimination, where we're going, is to continue the process after deciding what the equivalent expression would have been. And what we would do now that we have a variable that cancels is we would just add vertically. And what we would get is 0 x's and 0 y's equals 0. In other words, 0 x's, 0 y's is just 0 equals 0. So the solution to this system overall, if this wasn't just a simple multiple choice question, would be that if 0 equals 0 is the result, this is a true statement, which means that this statement forces the system to always be true despite what x and y are, which means this has infinitely many solutions. And again, I know I'm giving more information than the context requires, but leading into where we're going, elimination has these situations, these special cases where the variables fall off and yet infinitely many solutions. The answer to this question was just that bubble. So in this second example, what we're going for again is the x's. Last one could have been the y's, both the same. Right here we see that the 3 down below changed to a -6. So to make that happen, I had to have distributed a -2 across this bottom expression. So I need to do that correctly on my paper and then pick the right one down below. If I do so, I should have the bottom expression turn to be -6x minus 2y equals +8. The top expression didn't change. 6x plus 4y equals -10. Now, the answer to this problem is the one that looks identical to this bottom line, which is going to be this the solution over here in the bottom left-hand corner. This is the one that is written correctly. It's basically just setting up the first step of elimination. Now, carrying out elimination all the way through, which is what I'm going to do next, is where we're going and what we need to know how to do. Ideally, we cross out one variable, which this time the x's turn to be 0 x's, which is just a 0. It's gone. It eliminated. And then the y's we would add to get 2 y's equals -2. And then we would continue to solve for that first y and get y equals, divide by 2 here, -1. That's the answer for the y for this solution. There's going to be a single solution to this set. And then we take the y, this -1, and plug it into either one of these first expressions. I would plug it into the bottom one because there's less going on. And so I'd write it as 3x plus -1 in place of that y right there equals -4. And then I'd solve for x by adding this 1 to the other side. Plus 1, plus 1. And that's going to give me 3x equals -3. I'll write that again up here. 3x equals -3. And then divide both sides by 3. And I get x equals -1. So the solution set would be -1, -1. This is the coordinate where these two lines intersect, which is algebraically what we're after. And we're going to do that exact process in subsequent problems. But here for this problem, the context, we're just doing that first very step of figuring out what of these systems are equivalent by doing the first step of elimination.